So the next panel will get into the impact of robotics in product distribution and supply chain. And before we welcome our next set of panelists, we just want to give you a little bit of background on Cyngn and right-hand robotics.
Per Sverdsson has been building successful e-commerce businesses for the past 25 years. Now, he's building them for the future.
We want to be the largest pharmacy in Sweden. Our customers want us to deliver very fast and have a large assortment. To succeed with that, we need to have a very high automated system that is very efficient.
That's where right-hand robotics entered the picture. Apotea put RightPick 3 autonomous robotic item handling systems through a series of evaluations. Now, they were able to pick the majority of their products fast, but carefully, damage-free, all with the desired order accuracy.
We are always searching for new automation that is like future-proof. I really think this robot for picking is the future. If you look at it on like YouTube, as I did first time, I really saw that, okay, I can understand this. I can understand that this is the future.
Apotea launched a project to bring all these technologies together. Element Logic, the original and largest integrator of warehouses using AutoStore cube storage automation, was given the green light to proceed.
We started to work with right-hand robotics, and then we started to work with Element's AutoStore. Then we saw we could combine this, so we developed eOperator together with these two companies, and when they started to work together, it was like a perfect match.
Their eOperator solution is powered by right-hand robotics, meaning it's based on the same core technology Apotea already used elsewhere in the facility. These partners work closely together for a seamless automation. This provides a robust, continuous process flow that Apotea needs.
I think right-hand robotics is very focused on their customers. So our support has been fantastic from day one. So I think they really want to be a very large robot company, and they really show their customers that.
Apotea continues to invest the time and energy to build and sustain a great team of automation experts, including both their employees and key partners such as right-hand robotics. By using automation in an intelligent and flexible way, Apotea maintains close focus on the end customer, laying the foundation for continuous growth and profitability.
I can't predict the future, but I think the solution we have is like a formula for the future.
Did you know that if you want to bring full autonomy to your industrial fleet, all you need is one solution? Introducing DriveMod. DriveMod is Cyngn's end-to-end, fully autonomous vehicle technology. It's been designed from the ground up to bring a safe, flexible, and scalable autonomy solution to industrial vehicle fleets. DriveMod has been engineered with safety in mind. The AI models that power DriveMod were trained on the most complex driving domain of them all, urban streets. This rigorous training process ensures the safety of your autonomous vehicle deployment across a variety of domains. DriveMod doesn't end with self-driving technology. In fact, deploying DriveMod is just the beginning. With the help of artificial intelligence and easy-to-understand configurable dashboards, you can turn real-time data into actionable insights, helping you reduce costs across the supply chain, organize logistics more effectively, and predict when vehicles need to be repaired. DriveMod makes it easy to bring autonomy to the vehicles you already own. Tap into these future-facing capabilities today.
And welcome back to our fourth panel session. So we're talking today on the impact of robotics in product distribution and supply chain, and I'm excited to be able to host this discussion. And I'm joined by two industry colleagues that have some great insights on this. I'd like to start by introducing Sean Stetson, who is the Vice President of Engineering from Syngent. Welcome, Sean.
Hi, thank you, Chris. Well, happy to be here.
Good to see you. And I'm also joined by Yarrow Tenzer, who is the co-founder for Right Hand Robotics. Welcome, Yarrow.
Hi, Chris. Yeah, very nice being here. Thank you for the invite.
So all of us who've been going through life during the pandemic and the supply chain challenges and everything that's associated, to see these two videos is kind of like, okay, there's some really exciting progress happening behind the scenes. Maybe we'll have each of you just give a little bit of an encapsulation of where your robotics are, and particularly post-pandemic, and how they're really making some big strides towards supply chain management and product distribution. And I'll start with you, Yarrow, and then go to Sean.
Sounds good.
Yeah, this is a great question. I think what's interesting and exciting for us is that, our customers at the end of the day, they don't really buy robots. They buy solution that solves their problem, right? And if you look at our customers, one of the challenges in a facility is really predictability of how the flow, will go, like how many items can be shipped, how many items can be fulfilled, right? So a typical warehouse manager, they're really trying to understand these numbers, because, the more items you can ship from a facility, the better utilization of a warehouse. So in a way, what our robotic solution enable, and thank you for playing the full video and not just a portion of it, is really kind of give this type of predictability to the facility, right? So you know exactly at what stage the automation would work, the throughput, and you're really making the facilities kind of utilize it better. And so we really seeing in this phase where the warehouses, where they do want to kind of have this lights out operations, they are starting to leverage our technology, which is really exciting.
And understanding movement within the warehouse. So Sean, your robotics are doing a lot of movement of very critical materials. How are you better managing that? And to Yarrow's point, adding more predictability into where things are and where they're headed next.
Yeah, absolutely. So Syngent develops these autonomy kits, this whole autonomy platform that allows our OEM partners to take their powered industrial trucks and turn them into robots. And those robots then do automated material movement through the facility. So just like Yarrow was talking about in terms of predictability, that comes through that level of transparency and visibility that you get of the material movement, now that you have a robot who is constantly reporting its position and what what it's picked up and carried, because it's doing the job that you assigned it to do through our fleet manager platform. And so that visibility now takes what was an opaque process of manual movement and not really knowing where material is until it gets checked in at some particular locations into a upper level system, whether it's a WMS or an MES, and then provides full visibility. And then the fleet management monitoring it throughout its operations and really coordinating the movements of the robots and the jobs that they're doing, then allows that data analytics angle to inform how the operations are running, provide that that visibility into things, and also to inform continuous improvement efforts. So whether it's a manufacturing, distribution, or fulfillment center, the ability to basically automate this material transport helps reallocate people from non-value-added tasks to more value-added tasks that increase productivity and reduce costs, and also through the course of using these automated vehicles, improve safety.
So there's a couple of key things you both said there. So let's talk about the predictability piece. How are robotics giving greater insights to your customer base on where a product is in the fulfillment process, where it's not, probably equally as important, and giving more transparency to that now as we go forward? Can you either of you comment on that a little bit?
Happy to maybe start. I think in our case, it's really from a process point of view, goods are moving in a facility, and some of the goods, for example, stored in in kind of vertical storage or something somewhere else. But once you place your e-commerce order, that single item has to be singulated into the box, into the package, into something, right? And I think there are two areas there that we helping the companies. One of them is really kind of focusing on kind of doing it quite quickly, so we know the basic statistical distribution of how many which items will take what type of time, so we can help help the facility know by what time the process will finish. So for example, the facility needs to fulfill 1,000 orders of that type of a distribution. You can help and tell the facility when to order that specific truck, so it shows up and to pick up these goods, right? So that's one area. And second thing is, sometimes it's in a facility, it's really they really don't know the dimensions of the items, right? So they know something, for example, and I don't have a pill bottle in front of me, but but for a pill bottle, or for something like, for example, at Christmas, it will be like a 20% larger package, right? And suddenly, you really need to plan your supply chain for that adjusted packaging side. So in our case, every time our robots pick an item, they actually look at this and kind of double check the dimensions, or remeasure it, right? So if for whatever reasons dimensions are really off, like they say, hey, is that the right item? That's potentially one of them. So it's quality control. And second thing is like saying, and it's obviously happens in API in real time, is like, hey, this item is slightly bigger than expected. The process after that is really closing the box, is like, be aware that potentially there might be some challenges over there, or use a larger box, or hey, 1,000 boxes will not fit on this truck. So basically our robots help kick these processes if there is some variability that was not projected, expected, or anything like that. So these are the kind of two areas that kind of come to mind.
And the variability, Yaro, that you're talking about, Sean, when you look at your equipment that's moving around the floor of a warehouse, how are you deciding what to automate, what not to, based on the ebbs and flows of product distribution and supply chain? Can you give a little insight on that?
Yeah, well, I mean, that's a big collaboration with customers, right? So the customers today employ people to do jobs. They employ people to move material across a facility through the course end to end of their operations. Again, whether that's a warehouse taking stuff from receiving, or from the docks to receiving, from receiving to put away, or from receiving straight to point of use, and singulation, as Yaro was talking about, or induction into more robotic or other parts of the sortation center. That connecting all of those islands of automation, or islands of process, is what material transport systems do. And so we work with our customers to understand how they have to move that material, what sort of material they're moving, how often they need to move it, and the ways that the systems, their upper level systems, signal that need, and then produce a set of missions, basically, that through our fleet system, that then coordinates our vehicles to perform those movements. And then while it's doing that, back to that predictability angle, we can then encapsulate or track the time that it takes to do that same mission, to go from this part of receiving over to this part of put away, over and over and over again, and get a distribution, and then be able to inform better the operations in the future, or improve if there's a long tail of transport times. Then we can dig into why there's a long tail and start working on 5S or other efforts to improve that consistency.
It brings up a good point too. So some of the previous panels we talked about repetitive tasks, perhaps I think the word mundane was brought up, and as you're looking at repetitive tasks, what's that?
Dull, dirty, and dangerous, right?
Yes, exactly. The 3Ds. And so as you're looking at the 3Ds of the repetitive task, and you're trying to balance worker safety and maintain supply chain and order fulfillment, how are you prioritizing those, and thinking obviously of safety, but also making sure the throughput stays on track as it needs to? And particularly if you have a backlog in a supply chain that needs to be caught up in a way, where does robotics come into that situation?
Well, I think it comes back again to the basic application design. But as you say, safety is table stakes. You have to come in with a system that is designed to detect personnel and avoid any collisions, and avoid any incidents with personnel. Once you've met that level of requirement, then it's a question of really understanding the jobs and the frequency at which you need to do them, and planning the entire system to be able to handle that level of capacity, and how many robots versus that you need in order to do that work.
Yaro, from your side?
Well, I think in Sean's case, it's actually very interesting because there is more human robot collaboration, if you will, right? So if there are less humans, or the system doesn't identify humans, but theoretically speaking, you can move faster, right? And that's kind of I personally have been exposed to some of the systems in warehouses, not Sean specific, but some others, and I would challenge them. Like, I will try to stand in front of them and see how they respond, right? A typical engineer, right? So yeah, exactly. Let's see how it went break, right?
In our case,
yeah, in our case, it's much straightforward, because it's all about speed. Like, in our case, it's like, human, interaction with the robots is actually not needed at all. So there is like a cage around it, and there is a typical risk assessment that we do just to make sure that things are triggered off, or the robot is shut down if somebody is trying to get into the cell and things like that. But at the end of the day, like, our customers, they care about throughput, right? So they that's and the most protective way of doing it is just prevent people of getting into this area.
And there is, in most of these sites that we operate, there are definitely even manual drivers. There are speed limits, and we don't often attain the same levels of speed that manual drivers would. But what we find is that where our manual operations tend to be fairly bursty, the more consistent and ongoing, kind of the nonstop, if you will, efforts that a robot can put forth helps just smooth all of that out, and keeps the effective throughput the same or better.
And as you look at warehouse operations or supply chain operations, where are areas of growth opportunity for both of you in your business operations, where robotics maybe aren't being deployed as they can or should be, that could make a huge difference in predictability of product, predictability of the supply chain?
Want to start?
Yeah, well, I think in our specific case, our robots do require surrounding automation. So our robots do not move in a warehouse, right? So we usually, say, God bless all the companies that move the goods around our robots, right? So when we look at the market, we do track or stay in touch or interact with all the customers who are looking to deploy, more automation, and our technology is basically kind of, attached to this or being integrated as part of it, right? So it's not that you can show up to a facility and say, buy more robots. Like, no. You really need to have a facility that is, ready for that, or prepared for that, or has the processes that are already there, right? And so on one hand, it's kind of limiting factor because there is a specific market growth. On the other hand, we do have a lot of facilities, and especially if you look into this from international scale, like North America, of course, United States, like Asia, where there is a lot of challenges of finding the labor. So a lot of them are kind of going through the automation process. So especially after COVID, right? So it's really kind of being tied with other companies that are automating and be integrated into these facilities.
Yeah, and I'd echo that, and really anywhere where material is being moved with powered industrial trucks, that's an opportunity for Cyngn and companies like us to be able to automate those moves and really provide a more cohesive automation solution for customers that helps them to decouple basically their productivity from available labor.
That brings up a point too, Yaro. If you look at what are the biggest lessons learned coming out of the pandemic and the supply chain issues that we had globally, and how does that drive robotics adoption or more expansion of that type of operation going forward? What were your big takeaways, your big lessons learned, how it's guiding you going forward?
Well, I think for us, like, when we started the company back in 2015, which is like scary to think about, our assumption was that, that type of, e-commerce growth, like, the need for shipping individual items will continue to grow. So all of that was kind of, I don't know to say obvious, but it was like, that is what our society is going towards, right? That we, buy something online and it shows up at your door, right? So we were, I would almost say like early, with starting developing the technology, and the technology is really, really challenging, right? In many ways or form. Like for us humans to pick an item and place an item is kind of, table stakes, right? But to do it reliable, in the operational settings, kind of, 1,000 items an hour, it's really, really challenging. So I think what COVID basically showed, it really opened the eyes for a lot of, facilities, and saying, hey, we cannot get even labor here because people cannot get on the bus, on a I don't know, like, in the car, whatever it is, like, how do we operate and things like that, right? So a lot of these companies basically were exposed to these extreme conditions of like labor shortages, and that people are home and they're buying from home, right? Like nobody wanted to go to a store to buy anything, right? So I think that kind of a stress test, opened eyes to a lot of leaders and saying, oh, we really need to kind of replan our operations. And I think the challenge is that you cannot just drop our robots in the place. Like you do need to go through a process, and we're really seeing it now. Like saying, hey, these are the lessons learned. Like we need to operate, we need to emphasize, we need to optimize, and let's get there, right? So I think this kind of aha moment, did happen, during COVID, because the e-commerce, demand was much higher than the normal time. So
sure. And Sean, from your side,
I think one of the things that we as a society learned was, and specifically those producing things, is that centralizing your operations in specific regions is exposes you. And so there's a decentralization, if you will, of manufacturing and others that's reshoring a lot of capabilities and growing manufacturing really around the world, but specifically back here in North America. And at the same time, rather than having sites that are tuned or really specific to things that are more custom, more configurable manufacturing. So the ability of having autonomy, or ability of having more kind of custom operations or more variable operations really lends itself with some autonomy that is adaptable. So I think that's kind of where one of the things that's interesting.
And when you talk about the reshoring of manufacturing, how is that process is playing itself out? And companies are looking at human activities versus automation. What's the balancing act there to strike the right balance of keeping supply chains predictable and moving the way they need to, but also making sure that people have work, and that robotics comes in as well? How are you balancing those things?
Well, I think the key there is making sure that the people are being used in areas and for jobs and for value added parts of the production process that robots just don't do today. And that way, and then using robots for the things that aren't particularly value added, that the systems are capable of doing, like transport and other things. So I think that's where the balance is being struck, is making sure that you have the people doing the most important parts of the process.
Sure. And Yarrow, from you commented about work you're doing in international markets. Are there lessons you're learning from your robotics operations in Europe or Asia that you're incorporating into U.S. activities, or how you're kind of gleaning something from one part of the world and bringing it to another?
Well, I think when you operate internationally, there are different challenges with that, right? And it's really fascinating to be exposed to that. And that actually has nothing to do with robotics. I'll give you a specific, a few specific examples. First of all, in Europe, for example, they have a CE standard, so it's a safety standard. Mm-hmm. And to sell in Europe, you need to pass that CE standard, right? And when we started the company, we were like, oh, you're really trying to get your product out there as fast as possible to get validations. Like who thinks about CE? Like who cares, right? Because you're trying to prove that there is business first. And so when we realized that, hey, we cannot really sell in Europe without CE, like, it took us, something like about a year and a half, almost 2 years to get all the certifications, right? And when you're out of college and, you're not exposed to things like that, you're like, wow, that's a challenge, right? A second thing, to give you an example, is in the last, I think, 6 months or so, like we sell in Japan. And in the last 6 months, the yen dropped 50%. Which means that our systems became more expensive for them to buy. So suddenly the ROI on labor and things like that is not as attractive. And we do have some of our customers calling us and saying, oh, the price you charged before, now doesn't make sense to us. Is there any adjustments we can do to do it, right? So that's maybe a second example where you're like, oh, you as a company that's based in the US, being exposed to this market changes. And
Sure.
And maybe the final one is and I know we live it's in the current multinational world, but people do prefer buying from people they know and understand, right? So if you are an American and you're trying to sell, pick a country in Europe, like say French, right? The probability of somebody who speaks fluent French, selling something to the French country will be higher than an American selling. So like, hey, how do you build your sales team or go to market team that does resonate with the local population and can communicate in a using local values or local language, and so I think when you sell international, it's and I'll give you last example, right? With a CE, for example, right? So all the CE is like a lot of documentation like that, right? And all of this you submit in English, right? So that was the standard of Europe, right? But if you think about it, Britain, decided to peel off Europe, right? And so if you look back at Europe, there is no another country that speaks English, so it's why is this, CE documentation needs to be in English, right? And so anyway, I'm just showing you some examples that from international thing, which is when you start a company, you never think about, which is kind of fascinating. Sorry, I went too long.
No, it's a complex world, and then you add robotics in multiple languages, and it just gets more complicated. So, very good. How would you both assess the state of our supply chain right now worldwide? Are we back to recovery mode, or are we still recovering? And how is robotics going to play a bigger role in that if we're not back to recovery?
I mean, I think we definitely have the labor challenges that we've already talked about. In many ways, at least I haven't. We know that rates have come back down again. So in a lot of areas, the challenges that the pandemic imposed on the supply chain certainly have resolved. I think again, in the labor availability, that is certainly one that is continuing to persist, and will for the foreseeable future. So and maybe even get worse, some are expecting. So the setting there for the opportunity for autonomy and robotics to help close that gap, especially again on those tasks that are more non-value added and aren't things that there are things that autonomy can do well and humans don't need to do because again they're very repetitive. Is something where the opportunity is.
I think for me it's hard to comment on this because we were not that exposed to the challenges. I think we kind of navigated it, quite well. One area where I think there was a bit of a pain point is that our robots, they use GPU cards, so there is a lot of computational power. And when your manufacturer of GPU cards calls you and say, hey, we're planning to have this line of products for longer, but given the supply chain issues, we decided to stop this specific line of products and just focus on the next generation, right? So you're like, okay, now what, right? So we did have this kind of moment of what do we do? And for people who kind of haven't built many systems, the problem is, suddenly you have two types of products, basically. Like one have this GPU cards, one have this GPU cards. And how do you go through quality control? How do you make sure that every software release that you have will work on both of this type of configurations? And I think this is where the complexity goes into making sure that things are reliable. So we did have this a GPU kind of challenge, if you will, right? And it was something we didn't expect because when a producer of a GPU card says, we will support you for 5 years, don't worry about it, and you like plan your product for that, and then a few years into this, they're like, we changed our mind. It's like that's kind of sucks.
Right. That's a good way of putting it. So if you look at AI and the continued evolution of AI, how is that transforming and expanding the functionality of your robotic systems, your AV systems within the warehouse, making them more intelligent, making them more adaptable? Can you both of you speak to that a little bit?
Yeah, so we leverage AI in various areas, specifically neural nets for object detection and classification, as Yarrow mentioned before. When you have a robot, powered industrial truck, AMR carrying 10 or pulling 10,000 pounds, you want it to behave differently if there's a person in front of you versus a parcel. So, being able to incorporate that kind of AI into our products is certainly helping us to basically have more appropriate responses and behaviors. I think one of the areas that I'm really interested in and are learning about is the emergence of NeRFs or neural radiance fields in the opportunities for taking images and basically transforming them into full 3D models and really going from not just of objects but to full environments, because the environments that we operate in these industrial facilities have massive scale, millions of square feet, hundreds of actors all moving constantly all around it. And the ability of robotics companies to actually replicate in any level of realism that sort of environment in our test facilities just isn't there. So being able to develop full-scale models of customer facilities and simulate and train in those sort of things, in those sorts of environments in a realistic way, certainly helps to accelerate development. So I'm really kind of looking forward to being able to do that, not just in a kind of a synthetic environmental model, but actually a actual customer facility that we've then modeled and brought into a digital twin.
I think for us the AI aspect is really fascinating because when we talk about throughput, we usually talk about range of objects reliable at high rate, right? So when we increase the range of objects, this is where the data and AI helps us a lot, right? And I'll give you a specific case example. If some people come to us and say, our facility processes like clothes, and if we, can we just give your robots like a t-shirt like that, like not folded, like drop the t-shirt? Can your robot like fold it and put it in a box? Like, so the answer to that is no, right? We can handle anything that is basically packaged, right? But I think that where AI and data and all the advancements that are exciting happening is that, hey, we can upgrade our software over time and add these capabilities so these robots can handle an even wider range of objects, right? And so and more reliable at a higher rate. So for us, we are like that surfer who is in the right time and the right place and caught that amazing wave. Like we are really embracing it. It's quite expensive to be part of it, to be honest, because a lot of these engineering resources are not readily available, and a lot of big companies competing for them, and which is obvious. So as a relatively small company, it really takes a lot of kind of thinking, like, oh, what's our best bet? How do we leverage AI that is available versus developing our own, and how do we kind of operate it? So it's a balancing.
The balancing act. And Sean, you mentioned something a second ago about digital twin technology. Are you seeing more of that kind of factory of the future vis-a-vis a digital twin as the way to show what's possible before the live deployments? And do you see more of that happening going forward in your kind of design build operations?
Yeah, I definitely see more of it happening going forward. I think that it's not easy today, but it's just going to get easier, and that ability to model a customer facility and actually show them their operations being done with models of the AMRs would be not only an effective sales tool by increasing confidence in the system, but also could then be a planning tool to help understand the impact of surge events like seasonality, or even the what happens during something like a pandemic, and design appropriate workflows for that level of scale in the facility, or see if it's even possible. Because I've experienced a lot of seasonal surges at various customers that effectively disrupt the carefully planned and laid out automation, and facilities tend to revert to the status quo and go back to manual operations when that happens. And that change management process is so difficult that you want to be able to handle that without seeing that and having to recover from those sorts of events, basically.
Got it. We have an audience question. So what advice do both of you have for students who are interested in getting into the field of robotics? How to go about that, pathways, job opportunity? What does that look like? You have a lot of students who are following this discussion today.
Yeah, I think sorry, go ahead, Yarrow.
No, you go first.
Yeah, I think the opportunities are more than there've ever been, right? We have colleges like Carnegie Mellon that are offering robotics as an undergraduate program. We have lots of various disciplines that feed into robotics. And I guess my advice to folks is, one, absolutely, it's a great field. There's lots of opportunity. It's tackling some of the most impactful problems facing society. But at the same time, I would encourage not only people that are pursuing more technical domains or more technical subjects, but also those in design and human computer interaction and such, because in order for these systems to really operate well, they need to be able to be readily collaborate and easily used and interacting with humans. So I really I encourage students of all different disciplines to look into robotics and really get involved in all of the robotics clubs and opportunities, practice the discipline, even in school.
Yeah, I'll second what Sean is saying about clubs, meetups. I mean, there are like local ROS communities, there are local hardware meetups. There is different groups getting together, and it's fascinating. I actually went to one the Boston hardware meetup last week, and there were companies that are looking, like, asking and things like that. And as a I would encourage folks to really look at this time after college as an opportunity to get experience and really build this toolkit that they have of knowledge, because robotics is really broad. Like it's hardware, it's software, it's data, it's like a lot, right? And given my relationship to right-hand robotics, I get bombarded with emails saying, oh, I would love to work at right-hand robotics, right? At the same time, it's really challenging because we as a company, like we might be hiring from time to time, and the students should not feel discouraged by that they didn't get the job that at that specific company they wanted. Like the timing might be wrong, right? It doesn't mean that they are bad. They might be rock stars, but the timing might be just not the right timing, right? So look at this as like, hey, pick something, keep helping people, and at the end of the day, if you have the skill set, you will find your dream job. You'll get there. It will take some patience. It took me a long time to get to where I'm today. So.
Sure. And another question, as you look at the market 5-10 years out from now, where do you see the biggest investment growth opportunities in robotics?
Well, certainly right now the agriculture space. So, in some of the other heavier, sort of industrial. But really across the board. I mean,
I would encourage all the engineers to really try to understand the business case, because don't try solving everything with robotics. There are easier ways of solving things, right? And it doesn't mean that robotics is not valuable. There is plenty of opportunities, right? And second, Sean, is like, hey, if you look into agriculture, if you're excited about agriculture, like try to understand the business cases and where and how, before you start designing something. That's would be my encouragement.
And what would you both consider to be 2 or 3 of the biggest areas where robotics can make the biggest impact over the next 5 to 10 years? Problems that we haven't yet solved for that should be considered an area where robotics can play a bigger role.
I think one for me obvious is a bit of home automation. So anything in your household, and at the same time, it's a really challenging area because everybody's house looks different and nobody wants to pay for it, right? So everybody would love to have an assistant, but nobody wants to pay for it, right? So it's a very big design problem. And so how do you navigate it? And the reason I'm emphasizing it, because there are people who are willing to pay it, or there are ways of fun things like that. So I think home automation is definitely things that will be hopefully resolved in the next 10 years or so. So anyway, Sean, maybe you have some other ideas.
Yeah, if I think about areas that are a particular pain points, and I don't necessarily have applications at the tip of my tongue for these areas, but we already talked about agriculture, and I think there are a lot of opportunities there that people have already identified and are working towards to both use land and resources much more effectively and efficiently. But one of our big pain points is in healthcare and delivery of care, and whether robotics can, we're already seeing a lot of surgical robotics and those sorts of things, opportunities, but maybe even more in the transport and delivery of medicines or just supplies to various rooms to help spread save time for those delivering the actual care, like nurses and aides and everything to patients. So I wouldn't be surprised if healthcare is a big untapped area as well.
So I've got time for one last question, which is, help me finish this sentence. 15 years from now, warehouse and supply chain robotics will look like what?
Fully lights out. There will be no single person working on that.
Say that one more time.
There will be fully lights out from manufacturer to your house, to your doorsteps. There will be nobody touching the goods as they transition from a factory to your doorstep.
Sean,
Yeah, I suspect that the warehouses that we envision today of the big facilities will be fewer, and much more common will be the micro fulfillment centers that are far more distributed and closer to where the delivery of goods will happen. So kind of that decentralization of where things are stored and transported and sourced.
I agree.
Very good. Very good. Gentlemen, I think we're at the top of our time here. Thank you so much for your contributions and input. This has been fantastic.